Find at least one example of each angle relationship in the diagram. Name the angle pairs below and highlight the pairs of angles in the diagram. We'll use different colors to show that. So for vertical angles, I'm going to start with this intersection at H. So there's two sets of vertical angles at that intersection. The one I'm going to be identifying is FHA. So I got angle FHA. And I've got angle, again I'm looking at this angle through the vertex, which would be angle, this one, GHB. Now it's important to remember that vertical angles are at the same intersection, but through the vertex, so that middle letter for both of these has to be the same, no matter which intersection you're using. So yeah, it's important to remember too that, see how these lines go through the point of intersection. F does not have any lines that go through it. I mean, we could draw them going through, but they don't, so we wouldn't worry about that. Alright, then we got supplementary angles. For supplementary angles, it's important just to remember that these angles have to add up to 180 degrees. Supplementary angles, so I'm just looking to find a straight line that goes through another intersection like this one. Now for this one, I'm going to look at this angle, which was already identified. And it is 90 degrees, not that it matters, but that could be FGH. And we need another angle that would give us the 180, which would be this angle. And I'm going to identify it as HGC. Now finally we got complementariness angles. Complementary means that the two angles, and it has to be two, not just one, that they need to add up to 90 degrees. Now we know that this angle EGC, is 90 degrees because it's vertical with angle FGH. So we just got to identify the two angles that make up that angle. One of them is this one, EGD, and the other one is this one, angle DGC, and bam, we got a set of complementary angles on this specific figure. Alright, for the figure formed by the three intersecting lines, calculate the four missing measures. Justify your answer. Alright, so here's what I'm going to do on this one. I'm going to identify the ones that want. So angle AEC is this one in purple.
That's not a 90.
AED is this angle in red. DEG will be in black, green instead.
That's an acute.
CEB is this one, which is in gray. And then we also got this one, FEG, which would be kind of this whole thing like this. Alright, so let's make this bigger so we can work with it though. So let's start with the purple one. The purple one, first we need to identify that FEA is vertical with this 52 degrees, so we know this one is 52 degrees. That means this whole angle right here would be 52 plus the 35 degrees, which is 87 degrees. Next up, AED. So AED is supplementary with CEF and FEA, or we could just say CEA. So that means I can take 180 and subtract both of them together, we're 87. And I would get 93 degrees right there on this red angle right here. This was a straight line, a supplementary relationship with those other two. So instead of making it three angles, I made it one big angle, which was the 87 degrees. Alright, what about the green one? Right here. This one is vertical. Yeah, angle DEG is vertical with the 35 degrees. So it also has to be 35 degrees.
35.
And then we got the gray one.
CEB.
Which is, CEB, which is vertical with the 93 degree angle. Then we got this black one, FEG.
Wait,
That one is simply a straight line radical,
that's, so
which
it's
would have given
180
us, yeah, that 180
Wait,
degrees.
why CEB?
So let's fill in the table with the values we found. And let's just show the justification for these as well. That one was just the two ankles added together. I suppose we could have said that it was vertical with ankle DEB as well, but the way we solved it was by adding those two together because they were adjacent to each other to make this ankle AEC. What about AED? This one was supplementary with ankle AEC. So in other words, the two angles, 87 and 93, add up to 180. That's what's up.
Yeah, to add to.
And DEG, this one was vertical with ankle FEC. And CEB, this one was vertical with AED. And then finally, FEG is just one straight ankle.
So
All right, refer to this figure. It's not below, it's to the right. Whatever. In any case, we have this ankle AZU,
So
which is this ankle. Now, they already told us that ankle AZW is 27 degrees.
So would it be 93?
So yeah, let's acknowledge that this is 90 degrees, angle
Yeah, because
UZW.
there's like the little.
Which means that these two other ankles, UZA and AZW, are complementary. We're going to take that 90 degrees from ankle UZW, and we're going to subtract the 27 degrees from ankle AZW. And again, the reason that is because AZW and UZA are
63.
complementary, and that leaves us with the 63 degrees. Very good. So this is 63 degrees because,
Complementary.
yeah, the two angles are complementary. All right, if G is complementary to H, so the two angles are complementary, then G must be acute because the two would add up to 90 degrees. In fact, we can find the measure of G would be 70 degrees because the two, again, have to add up to 90 degrees, which is complementary. If angle B is supplementary to angle C, which is 180 degrees, and angle C is 90 degrees, then B also must be 90 degrees, which is a right angle. If angle D is vertical to angle E, then they're the same, and angle E is 150 degrees, then angle M must be obtuse. Determine if the statement below is always, sometimes, or never true. If sometimes true, give an example when it is. If false, and when it's false. If it's never true, we'll give a counterexample. All right. Adjacent angles are also supplementary angles. That is false. And here's why is, if we had this ankle and we split it right here, then these two ankles are, they are adjacent, but they are not supplementary.
Wait, so it falls.
Oh yeah, so that it's sometimes is what I would say right there. So this would be false right there, right? So let's go back and change that to sometimes, right? So this would make the example false. Well, let's look at an example that would make it true. So if we had a straight line and we split it up, then we have this angle which is adjacent to this one, but the two make up this straight line radical.
So it's 180.
So that's why it is sometimes. This would be when it is true. So 12, this one's looking at vertical angles are complementary. This is rare, but it's still sometimes. So for number 2 here, let's look at the case where it is true. So that's where we have a line like these, and then maybe something like this. So the only reason, complementary, by the way, is 90 degrees. That means that this angle would have to be 45 degrees, which would make this one 45 degrees. And since those two vertical angles are the same and add up to 90, that is what makes this one true. But again, it's very rare for that to happen, because something that would make it false would be something
Like
like
50?
this. Like if that's a right angle,
That's a right angle.
then all the other ones are right angles, and that would make it false.
Yeah, because there's... Yeah.
If one of two adjacent angles is 70 degrees, the other is also 70 degrees. So let's look at what would make this true. So if this is my line, and then I got a 70-degree angle right here, I can make the other angle next to it also 70 degrees. And that would make these two, that would make our statement true. But something that would make it false, again, would be something like this one right here. That would also make it false, because we have two angles that are not 70 degrees. Or I guess we could make one 70. So let's do that. So this is about 70 degrees right here. The other one we could just make a straight line. See, now this is obtuse.
Yeah, but...
So this one is not 70 degrees. And that would make it a falseness.
Wait, what?
Vertical angles have the same measure?
Yes.
Always.
I knew it.
And 15 perpendicular lines will never intersect. That's false. No, they will always. I'm sorry, that one is a never. Yeah, never. They will never intersect, meaning they will always intersect. So perpendicular lines are lines that are related by 90 degrees. So if I have this line, automatic, no matter where I put it, if this one is perpendicular to it, it will have to intersect at some point, which would make it 90 degrees, which is a right angle, which makes the two lines perpendicular. So no, they will always intersect.
90 minus 32.
For numbers 1 through 6, use angle relationship, complementary, supplementary, vertical to write a simple equation to find the missing angle. Then find the measure of the missing angle. Yeah, so since this is 90 degrees, that makes the relationship complementary. So we got 90 degrees. One of the angles is 32 degrees. So that would give us 8 and 7, 48 degrees. No, 58. 58 degrees would be M. The equation, though, would be that 90 minus the 32. 50, not 50, 58. All right, on number 5, these ones are supplementary because we have our straight line right here. So that means that it's going to be a total of 180 degrees. But again, one of these angles is shown as 58 degrees, so we're going to subtract 58 degrees to get the value of M. So 180 minus 58, 122 degrees. Number 2, this one is complementary. So this angle right here is 90 degrees. And again, we got this, just this angle is 53 of the 90, so we got to take that out. And that would give us the value of M, which would be, very good, 37 degrees. So again, this gives us a straight line, a supplementary relationship, which is 180 degrees. And one of these angles is already 27, so we'll take that off. And that will tell us the value of M, which it appears would be 153 degrees. For each of the following, write an equation to find the missing angles and then find the missing angle. Two angles are supplementary, so that's 180 degrees from the supplementariness. They are equal. What are the measures of the two angles? So that means we're going to take one angle, but the other angle is the same, and we need to add those together. So if we do that, we'll make this 1x and 1x. That's right. That's correct. So that would give us 2x's. I'm using the equation either way. Then we'll divide both sides by 2, and that would tell us the measure of not just one, but both angles, because they're the same, 90 degrees. Two angles are complementary. One angle is 4 times the size of the other. What are the measures of the angles? May be helpful. See a diagram of this. So it's 90 degrees, right? So we're going to have that 90 degrees. But this has been split up like these. And one angle, let's say that this is the smaller angle. So it's going to equal that x. But the other angle is 4 of those, 4 times that value. So if we combine the two, then we get 90 degrees. Now we can't forget that's a 1x. So when we combine these, we got 5x's, which is 90 degrees. And if we divide both sides by 5, that will tell us the value of x, which is 18, it looks like. So the small angle is 18 degrees. The big one is 4 times that. So we'll do 4 times 18, which would be 72 degrees. So this is one angle, this is the other. We can check by doing 90 minus 18 as well, which also is 72 degrees.